Hey everyone, welcome back to the Galaxy of Codes. Today we are solving one of the most famous dynamic programming interview question, Decode Ways. Most people memorize this solution, but today we will derive the DP from scratch. Starting understanding every bit line, so that even if you forget the code, you will still be able to rebuild it during the interview. So first of all, we'll be understanding the concept, we'll be understanding each beat portion and words also. And then, so before we start solving lead code principle, first we'll be observing our 5C principle, 5C principle of solving any lead code question. So let's minimize it so that we can observe the 5C principle. So okay, this is the 5C principle you can see in the board. Okay, this is the 5C principle. So before solving any lead code problem, you should keep in mind of this 5C principle. That is first comprehension, second constraint, third case simulation, fourth constraint, and fifth the code crafting. Comprehension, that means in this portion, first we'll be going through the entire question. We'll be trying to understand the question in the comprehension portion. Then constraints, we'll be observing the constraint. Then we'll be observing the constraint. If you notice, this is the constraint portion. Then we'll be observing this constraint portion. This is very much important portion for solving any problem, the constraint portion. After constraints, we'll be observing the case simulation portion. Case simulation will be observing and trying to figure out from each cases. Then will be construction of connections, that means pattern mapping. We'll be trying to figure out what pattern this is, what the pattern is driving from there, and then we'll be crafting the code. So this is the 5C principle that you must follow while solving any lead code question. So let's move to the comprehension portion. Okay, so now we are in the comprehension portion. First, let's understand what the problem tells. You have intercepted a secret message encoded as a string of numbers. That means we have intercepted a string message encoded as a string of numbers, like this. That means we are provided with a string that is containing the number. So let's take it. String that is containing number like 12. The first line of question tells. Now moving in the second portion. The message is decoded via the following mapping. So that means we decode the message like we map like this. 1 is decoded as A, 2 is decoded as B, 3 is decoded as C, and 26 is decoded as Z. So let's map it in our brain. So we are mapping the question like this. 1 is being mapped with A. 2 is being mapped with B. 3 is being mapped with C. And so on in this way. 26 is being mapped with Z. So this is how we are mapping in our brain, in our system. Now let's look the next question what question tells. However, while decoding the message, you realize that there are many different ways you can decode the message. So while we are studying the question, we realize that there are many different ways. 1 way, 2 way, 3 way. There are many different ways how we can decode the question. Because some codes are contained in other codes like 2 and 5. So let's take an example of 12. And if you notice this 12, that we can decode this 12 in two sections. Number one, if we decode one by one, that we are decoding first, we're moving from this section, just for understanding. So we are decoding one character at a time. So we are decoding like 1, 2. So this is one way of decoding. Now the second way of decoding, that we are entirely decoding the entire portion. That means we took the entire this one 12. So this is the decoding, and the portion is 12. And this is 12. We have decoded the entire portion. So notice how many ways we can decode. That is 2 ways. That is one character at a time, 2 character at a time. So this is the ways how we can decode. That is one character at a time, one character at a time, one character at a time, and 2 character at a time. So this is, so total number of ways by which we are decoding here is 2 ways. So this is 2 ways that we are decoding. But if you notice, if the program becomes larger, let's say they have given an example of 1106. Now we are noticing this one 1106. What the problem is telling 1106. So 1106. So if we decode it, we can decode this one like this way. The problem tells that we are decoding like this: 1 1 1 1 1 1 10 6. This is a one way of decoding. Another way of decoding, that is 11 10 6. We have taken 2. So what the decoding becomes? Decoding becomes like this: A J and 6 for F, K J F. So this is decoding. So did you notice for 1106 we have two ways of decoding? So this is how we are decoding here. And now notice another decoding here. Another decoding, that is 1 11 06. But what the question tells, the grouping 1 11 06 is invalid. The grouping 1 11 06 is invalid because 06 is not valid, only 6 is valid. So 0 is not valid in our system. So what the problem tells here, that our this situation, this answer is invalid. This is invalid. And you might be thinking why this is invalid? Because it is containing 0. We don't encounter 0 as valid system. So if our program contains this 0, that means if our string begins with that 0, so that is invalid. That will contribute 0 contribution. That will make 0 contribution. If something is beginning with 0, so that will make 0 contribution. And this is the point we figure out from here. This is one important point that we figure out from this 06. Keep in mind. So this is how we can decode, and we have to take the valid ways of decoding. So these are the two valid ways of decoding. So total 2 ways. Now let's move what the problem tells next. Note there may be strings that are impossible to decode. So there might be few strings we cannot decode totally. Given a string yes containing only digits, so they have ensured that the string yes is containing only digit 1 2 3 4 5 6, nothing more. Return the number of ways to decode it, and we have to return the number of ways to decode it. So what that gives us the objective. If we notice the objective, okay, the objective, let's write objective. Actually, I like using some goal type of thing so that we can understand better that is the objective. Okay, convert. So this is our objective. We are marking like this, that this is objective important portion. So what is our objective? They told us in the question, if you note, that return the number of ways to decode it. They are telling in the question that return the number of ways to decode it. So we write it that return the number of ways, return the number of ways, return the number of ways, return the number of ways to decode it, return the number of ways to decode it. So they tell us these things in the program. That means this becomes an important portion of our decoding, that we have to return the number of ways to decode it. And what becomes in dynamic program is that what is our objective, that becomes our state. That becomes our state. So currently, because this is our objective, so dp of I, so we define our state dp of I. So our state dp of I becomes this one, dp of I, that is equals to, this is our state. So dp of I objective becomes our state. So dp of I becomes I. But notice here is I. So we cannot tell that return the entire string. I provides us the range. I tells us the range. I denotes the range. So range of the objective, that is return the number of ways to decode it, but up to the range I. Okay, I tried making you understand it. Now we will be observing through a visual the entire flow diagram, how we can construct it very easily, and then we'll be moving toward the code portions. Let me slide it. Okay, so let's notice it from the beginning through this visual. So we are discussing the Decode Ways problem, dynamic programming flow. So first of all, the problem. Okay, this is the problem. So what is our problem telling is that we have to decode. A message is encoded as a digit. Yes, our problem is telling is that message is encoded as digits. 1, and we can map like 1 to A, 2 to B, 3 to C, 26 to Z. and the objective is that return the number of ways to decode it. So the number of ways to decode it, return the number of ways to decode it, that is the objective. So as per the problem, this is our DP state, that DP of I. This is our DP state, DP of I or DP of MN, whatever. Now we come to the DP state. Note, the DP state, that is in DP of I. DP of I, that is number of ways to decode the first I character of the string. DP state. So we are defining the DP state. The DP of I, that is number of ways to decode the first I character of the string. So this is the DP state, the objective of the main problem. Whatever the problem is, the objective becomes the DP state. So after DP state, we move to understanding base case. So what might be the base case in dynamic programming? Dynamic programming, or in any cases, the base case always becomes 0. That what if the string becomes empty, that type of scenario. Or the second scenario arises, what if there is only one character? And we noticed one important thing here, that preceding with 0. The preceding with 0, this is also a matter of consideration for base case. So these are those come in base cases. Let's notice. First of all, DP of 0 equals to 1. That means empty. If this is an empty string, that is an empty string, so there is only one way to decode it, that will do nothing. We'll be doing nothing, and that will be our way of decode. So this is DP of 0 state, that empty string has one way to decode. Empty string has one way to decode, is doing nothing. So we count that as one way in programming. So this is base case. DP of 1, that is equals to S of 0. Now the second case, if the scenarios like 06 occurs, so how many ways we can decode it? We cannot decode it because our system didn't allow us. Our system didn't allow this type of decoding. If something starts with 0, so that is not a valid decoding. So simple, that one. The DP of we are defining the DP of 1 state. That means if the first character is starting with 0, then we initialize 0, and if that is not starting with 0, then we substitute that with value 1. That means if not starting with 0, there is one way to decode. Now the transition begins. Now we start performing the transition operation for I from 2 to n. So transition begins from 2 to n. Suppose there were problem like 112. So for simplicity and programming understanding, we begin from 2. That means we start our programming operating from here, so that we can take previous values from this range and previous values from this range. So when this is 1 1 2 1 1 2, when this contributes, it makes one contribution, that is we take one digit. And when we take both the digit, so we take 2 digit, it comes here. So based on the conditions, they move to 1 and 2 digits. So we are moving this one, that is x I minus 1. So if at any situation I am here and I want to access previous digit, so it becomes I minus 1. That is if s of I minus 1 is between 1 and 9. So if 1 and 9, that means we are checking the range of one digit only, so it must be between 1 and 9. So this is, then we add the contribution, because we have to add the total number of contributions. So DP of I plus equals to DP of I minus 1. Second, when we actually include 2 digit 1 1 2, we are at this position I, and we want to access up to 2 digits. This is I minus 2 position. We're moving back up to what position? I minus 2 positions. So for that scenario, it becomes we add this contribution to our current DP state, that we are adding DP of I plus equals to DP of I minus 2. So this is that when we are taking 26, take 26 together. This is the scenario when we move from this position back. Now we combine both the scenarios. Possibility 1, when we take one character. When we take one character, and possibility 2, when we take two character. When we take two character, they combine each other, and this becomes our combined DP state, that DP of I equals to DP of I plus 1 plus DP of I minus 2. So DP of I, this state now becomes DP of I minus 1 plus DP of I minus 2. Because for the first scenario, we take only one character. For the next scenario, we take both the characters. Now the answer, total number of ways. And this was our main objective. Look, this was our goal. This was our main objective we highlighted also. The total number of ways. So the total number of ways keeps increasing in the dynamic programming. And at the end, this last value or the ended value in here, that is DP of n, actually contains the answer for the entire string. So this DP of n will actually return the answer. And this is the flow in better way. That is example walkthrough 226. So we are rocking 0. We are handling empty case. Notice. Then 1, 2, 3. we took one character, then we took 22, then we took 26. Lekin this is not valid. This will not be performed operation. So we will take the contributions from here, here, here. So total contributions 2, and when it encounters 226, it takes contribution from here and it takes from here. So that actually becomes 3. So that is our DP state, DP of 0, 1. That is no valid one. I mean, we take not. So this is 1, dp of 1 is also 1, dp of 2, that is equals to dp of 1 plus 1, dp of 3, dp of 2 plus dp of 1. So this is how it keeps adding. It actually, dp of 3 takes contribution from back 2, that means 1 step back and 2 step back, and the contribution is done from here. Important rule. So this is a rule provided by the system that 0 cannot stand alone. 0 cannot stand alone. Only 10 and 20 are valid with 0. Yes, those types of valid number must be in the range. So we must check always in the ranges. I hope you understood the problem scenarios, how it actually works. Now, so we'll be moving now towards the programming factor. So let's move toward the coding zone. Okay, now we are coming to the programming. So this is the problem case simulation 12. That is the case simulation 226. So while I was trying to make you understand of the problem, we have simulated all the cases. So now we actually move to the programming entirely. Okay, so we are in the programming zone. Public integer number of decodings. So first of all, let's calculate the length. Integer n, that is equals to s dot length. So we calculate the length first of all, the string. Now we need to define the DP state. We need to define the DP state. A question might arise in your brain that how do you understand this is a problem of DP dynamic programming? So let's notice the constraint. This is the importance of constraint, that if you notice the constraint, for every DP problem the constraint is very small, 100, 200, 500, 20, that type. So DP is actually a brute force, but this is optimized version of brute force. DP is brute force but optimized version of brute force. So this are so small, whenever the state is very less than 100, 20, we must understand that this is brute force, and from brute force we should follow the optimized version, that is DP. So integer array DP, that is new integer n plus 1, because we need to handle the empty case also. So now we fill base case. Empty string has one way of decoding. Empty string has one way of decoding as per dynamic programming, that is choose nothing. That is one way. Empty string has one way of decoding, choose nothing. So DP of 0 is filled with 1. Now if the string begins with 0, notice 06 cannot be mapped to f. So if our character begins, that means our character begins with 0, so we cannot include that character. So after the DP of 0, we define the DP of 1 instead. So we check if the first character, if the character at 0 position is not equals to 0, then 1, and if that is 0, so we check if the first character of the string, yes. We check if the first character of the string yes is containing 0, that is 0th, that is at I equals to 0, first character. If that is 0, then it will make 0 contribution. So we'll be simply defining DP of 1. DP of 1 equals to s dot character at 0. S dot character at 0 not equals to अगर 0 हुआ, अगर वो not equals, if that is not equals to 0, then we'll be assigning that one way. मतलब 0 ना होकर वो 1 2 3 4 5 6 कुछ भी होता है, then there is one way of decoding. And if that is 0, so that will not contribute. So 0 way of contribution, 0 way we can decode that one. So now we are handled for both the cases. Now we'll be building the DP state forward, building DP state step by step forward. So we have handled the 0 case and the 1 case. Now we start building from 2 case. For integer I, that is equals to 2. I less than equals to n, the total length, I plus plus. So first of all, what we'll be doing, that we'll be extracting just the back character. So now adding the contributions, from previous for just one character, so we are handling the case of one character only. So first of all, we extract the character one digit, that is equals to s dot character at I minus 1. Now we check if the character is not 0, if this one digit is not equals to 0, if that is not equals to 0. If this one digit is not equals to 0, then it will make a contribution to the dp of I plus equals to dp of I minus 1. Done. So it is now making contribution. Now we are extracting the 2 digit. Now adding the contributions for just 2 character. Now we are adding the contribution for just 2 character. So first of all, we will be extracting the 2 digit, character 2 digit. So extracting character 2 digit. So we cannot extract character just like character, because character is a 1 digit value. So we have to extract as directly as 2 digit. So integer 2 digit. Notice we are extracting as integer because character will be of 1 only. That cannot be of 2 digit character. So integer dot parse integer s dot substring. So we are starting including from I minus 2 back position and up to I exclusive. Notice I is not included in the substring, so this is excluded automatically. Now we check if 2 digit is greater than equals to 10 and 2 digit is less than equals to 26, then yes, they will make a contribution. Then dp of I plus equals to dp of I minus 2, they will make a contribution. Now at the end, dp of n will return as a value, so we return dp of n. dp of n contains the total number of ways. The objective, return the number of ways to decode it. So dp of n contains the total number of ways to decode. And now let's notice if you face an error. So yes, primarily it has been accepted at the, let's see for all the examples. I'm actually being panicked why the solution is not being accepted. Let's wait. Okay, the program should actually submit, and I have submitted a lot of times. Sometimes actually LeetCode goes down and that type of error might have come. So we are closing this video session here. If you find any problem, do comment to me. And this is actually a successful working code because I have submitted tens of times. I have practiced so much times. So okay, meeting in the next session.